and welcome to Master at the Morley Academy. I'm going to be going through some questions for OER GCSE paper, and you find it useful. So the first question that we're going to go through says, a box contains only red, blue and green pens. The ratio of pens, red pens to blue pens is 5:9. The ratio of blue pens to green pens is 1:4. Calculate the percentage of pens that are blue. Now the reason why we're going through this question is this is a question that a lot of students kind of underachieve on, and we really want you to be able to be successful in your next mocks coming up in February. So here we go. So this is going to be 4 marks, so just think about the amount of steps that you have to take to get there. Okay, so I have red, blue and green. So I'm going to put red, blue, and I'm going to put green. Okay, that's the first set of information. The ratio of red pens to blue pens is 5:9. So red to blue is 5. Okay. The ratio of blue pens to green pens is 1:4. So blue to green, 1. Normally, this is where students get really confused. They think, where can I go from here? But if I know that 1 blue is going to be 4 green, it means that 9 blues is going to be 9 times 4. Okay, so if I multiply that by 9, that's going to give me the answer that goes right there. Okay, which is going to be, in this case, 4 times 9, 36. I'm going to put 9 onto there, and I'm going to say that my red to blue to green is now going to be 5 to 9 to 36. Okay, this is really crucial. We are now having all the ratios lined up with the 3 colors, and it makes it much easier to analyze. Now, when we're talking about ratios, the first step is always to add them together to get your total. So if I write it in steps, step 1, I'm going to add the ratios. So 5 plus 9 plus 36 is going to give me 50, and that's my total. Okay? Okay, so let's read what the question really wants us to figure out. Calculate the percentage of pens that are blue. Okay, so I'm talking about blue. Now the way you work out your percentages is you look at the amount for the specific color you're looking for, you look at the total, and we know that percentages are always out of 100. Okay, so if I want to work out the percentage, I need to put the amount that I'm looking for over the total, and I'm going to times that by 100. In this case, the amount that we're looking at is 9 blues. The total is 50, and to make it into a percentage, we times it by 100. Okay? Now that's going to give you 8%. Now let's look at the mark allocation. If I can successfully make one line of ratios by using my calculations above, that gives me 1 mark. Okay? 1 mark is allocated for adding your ratios up together, so that's really important. Okay? Being able to work out a percentage by having the amount divided by the total and times by 100, that method gives you 1 mark. And for your final answer, that gives you your final mark. Now, in the exam, if you have a calculator, that's brilliant. You can just put that into your calculator, 9 divided by 50 times by 100, and that goes ahead and gives you 18. However, if you don't have a calculator, what you can do is say, 50 goes into that once, 50 goes into that twice, 2 times 9 is 18, and you get your same answer. So whether you've got a calculator or not, you're going to be good. Okay? Next question. Now this question is one that I think really needs to go through slowly so that you definitely understand it, because it's one of those questions that students get really confused on, and actually once you have a good go at it, you'll realize it's quite simple. Okay, So Sam and 2 friends put letters in envelopes on Monday. The 3 of them take 2 hours to put 600 letters in envelopes. So what I like to do is I like to take my words and make it into almost like an equation. So if we have a bit of space up top here, let's have a go. So 3, 2 hours, 600 letters. So I write down 3 people take 2 hours and they distribute 600 letters. Okay? And it's really good in mathematics to make sure that you can convert or change your words into as simple instructions as possible, because that helps you. Okay? Now, it says on Tuesdays, Sam has 3 friends helping. Working at the same rate, how many letters should the 4 of them, okay, be able to put in envelopes in 2 hours? So, I know that the time is not changing, so time is not changing. However, the amount of people is changing. Now, the first key bit to do here is to change my 3 people into 1 person, and then I can convert that into 4 people. Okay, so let's have a go. If I have 3 people for 2 hours doing 600 letters, I know that 1 person, okay, over 2 hours we went from 3 people to 1 person by dividing by 3. So I'm going to go from 600 letters by dividing. I'm going to get you always variables the same. Remember, the time is now I want to figure out for 4 people. So if I want to go to 4 people, okay, okay, so if I multiply by 4, that's going to give me 800 letters. B letters. Now think, you get 1 mark for doing person because you don't work out 1, okay, and also you get another mark for working out your 800 letters. So going from 3 people to 1 person, 1 mark, and going from your second step to your final step, which gives you your final answer, gives you your 2 marks. Okay? So remember, there's always 1 variable that stays the same, and you make sure that you make it very clear that that's staying the same, but we're changing the amount of people. Okay? Moving on to the second section. Now, working at the same rate, how much longer would it take 4 people to put 1,000 letters in envelopes than it would take 5 people? Okay, so let's calculation. We worked out 1 person takes 2 hours to distribute 200 letters. So I'm going to use that information to help me here. So 1 person takes 2 hours to distribute 200 letters. Okay. Now if I want to go from 1 person to 5 people, we know that you are going to times by 5. Okay? Okay, so I'm going to times by 5 on that side as well. And that gives me 1,000 letters. Okay, so this is kind of your first calculation. Okay, now if I want to actually work out 4 people, you've got to actually be really, looking at this. So one person, okay, is 2 hours, and that gives you 200 letters. Okay, but if I want 4 people, okay, I'm going to multiply that by 4. Okay, and if I multiply that by 4, that's going to give me 800 letters. However, it clearly states that it wants 4 people to give it 1,000 letters. Now, the only way to get from 800 to 1,000 is to multiply it by 1.25. Okay, now we want the amount of people to stay the same. So we're going to have to multiply the time by 1.25. Okay, and that's going to give me 2.5 hours. Okay, now once again, you always need to keep one variable the same. So here I'm keeping the 4 people the same, but I'm changing the amount of letters, I'm changing the amount of hours. Okay, now 4 people is taking me 2.5, 5 people is taking me 2 hours, so therefore if I want to find out how much longer it was going to take, we're going to say 2.5 hours take away 2 hours, and I know that the difference is going to be 30 minutes. Okay. So this is one that has a lot of bits to it, but it really is worth the 4 marks. Now, how do I get the 4 marks? I get 1 mark for working out 1 person. I get another mark for working out for 5 people. I get another mark for working out for 4 people. And I get my final mark for making sure that I minus my 2 answers from each other. So that's 4 marks. Okay. Going on to the last bit of this question. Sam says it took 2 hours for 3 people to put 600 letters in envelopes. If I assume they work all day, then in 1 day, 3 people will put 7,200 letters in envelopes because 600 times 12 equals 7,200. Why is Sam's assumption not reasonable? Now, the reason why Sam's assumption isn't reasonable is because Sam is assuming that a whole day or all day, okay, means 24 hours, okay? So I would write down Sam is assuming all day means 24 hours. Okay, however, this is not reasonable for them to work this amount of time without a break. And if you think about it, it really is reasonable. You don't think of anyone working that amount of hours straight without any break. So therefore, that's the assumption that Sam is making. Now, this is worth 2 marks in the exam, okay? So writing the assumption that Sam has made gives you 1 mark. The other mark comes from the effect, okay? Now, for my second mark, I would write down they cannot work at that rate for that long. Therefore, the calculation would not be correct. Okay? Right. So I do hope you find that useful. Now moving on to the last and final question. Okay. It says, John is going to drive from Cambridge to Newcastle. So on our little map we have Cambridge and we have Newcastle. Okay. It says John needs to be in Newcastle at 11 a.m. So he needs to be there at 11 a.m. Okay. Now it says he drives at an average speed of 60 miles per hour. So 60 miles per hour, 60 miles per hour. Okay. What time does he need to leave Cambridge? So what time does he need to leave? Okay. Now a question like this is really important because it really is asking you to really think about speed, distance and time. Okay. Now, if you've not learnt this before, speed equals distance divided by time. So if we're trying to calculate the time, time equals distance divided by speed. Okay. Now, first we need to measure the amount. Now on the top of our paper it says the scale 1 centimetre represents 50 miles. Okay. Now if you have a ruler, what you would do is you would use your ruler to measure from Newcastle to Cambridge. Now if you measure from Newcastle to Cambridge, which I've already done before, Newcastle to Cambridge, that is going to give you 4 centimetres. Okay, which is great. Now, if 1 centimetre equals 50 miles, then 4 centimetres is going to equals 200 miles. And that is going to be our distance. Okay, and that's really important. Okay, now remember, we have the speed. Okay, we have the distance and we're looking for the time. Okay, so if I want to work out the time, time is going to be my distance divided by my speed. Okay, now if you use a calculator, that is going to give you an answer of 3.3. Okay, and that's going to be hours. Now 3.3 is the same as 3 1/3, and 1/3 of an hour is 20 minutes, so the equivalent is going to be 3 hours and 20 minutes. So I know that if I want to get from Cambridge to Newcastle, it's going to take me 3 hours and 20 minutes. Okay, I need to get to Newcastle by 11 a.m. so I'm going to count backwards 3 hours and 20 minutes, and that's going to give me my answer. So therefore, John needs to leave at 7:40 a.m. Okay, now if you struggle a bit to kind of work that out, you can put 11 a.m. to 10 a.m. to 9 a.m. to 8 to 7 and just say 1 hour, 2 hours, 3 hours, and then you have 20 minutes. So 20 minutes means that it's going to be 20 minutes on this side, so 40 minutes on that side, and therefore it's going to be 7:40. And hopefully that is able to help you. Okay, last question. It says, state one assumption you have made. Explain how this has affected your answer. Now, one assumption that John has made is that, once again, he is assuming that he's not going to take any breaks. Okay, so my assumption is that John has not taken any breaks. Okay, explain how this has affected your answer. It would give me an overestimate as it would take a longer amount of time. Okay, so once again, let's look at the mark allocations because that's really important. You get 1 mark for converting 4 centimeters to 200 miles. Okay, you get 1 mark for working out the amount of time. Okay, you get another mark for changing or converting the hours into hours and minutes. Okay, and then you get your next mark for working out your calculation for your speed. And finally, 1, 2, 3, 4, final mark for working out your time. Okay, so your final answer, you get 1 mark for your assumption and your final mark for how it would affect your final answer. Okay, so I hope that really helps you because those are really key questions that students normally get wrong in the exam, but we hope that now we've gone through it with you, that will give you a real advantage for February. Okay, all the best. Thank you.